Hello guys, welcome to my channel Fundamentals of Engineering. In today's session we are going to see another angle measuring instrument, that is Autocollimator. In today's session we are going to see what is the working principle for the Autocollimator, how the Autocollimator measures a small deviations, that we are going to see what are the equipments used in this equipment, what are the applications where we are using this Autocollimator, for what angle measurement, that we are going to see, then its merits and demerits, that we are going to see in today's session. Before starting to this session, I request everyone to subscribe my channel, click on bell icon to get more notifications. So if you've seen, the Autocollimator is an optical instrument. It is used for measurement of small angular differences. For small angular measurements, Autocollimator provides a very sensitive and accurate approach. Thus, Autocollimator is especially an infinity telescope and collimator combined into one instrument. So now we are going to see the working principle of Autocollimator. For that, we are having a focal plane. In front of that, collimating lens is there, and the reflector from where the light is reflected. So this is from the point source, the light is coming out and it is collected at the collimating lens and it is transferred to the reflector. When this parallel beam of light is transferred to the reflected, if this beam now strikes a plane reflector which is normal to the optical axis, it will reflected black along its own path. So this is a parallel reflector, so it is reflected from its own path. You can see all the lights are reflected from its own path. So you'll get whatever the light which is coming from the point source, which the reflector is perfectly flat and parallel to this lens, which is normal to the light rays. Then whatever the light which is reflecting from the reflector, it is coming back at the point source itself. Now if the reflector is now tilted through an angle, small angle, if the reflected it is tilted to some an angle, then what will happen? If it is reflected with angle theta, then whatever the light which is coming from the point source which is falling on the collimating lens, when it is fall on the reflector, at an angle theta, the reflector is tilted. Whatever the reflected light which is getting from the deflected from the reflector, it will be with the angle of 2 theta, and we'll get one rectangle where the point source from the A to B, the rectangle which is forming. From this rectangle, if you see that angle which is reflected with the theta, that then the reflection angle we are getting based on the principle of reflection, that is angle 2 theta. Then if you see the triangle ABO, where the distance AB, that the reflection light from A to B, that is X, and A to O, that is focal length, based on that we can calculate the distance AB, that is X, which is twice the angle 2 theta. So you can see we can calculate the deflection, that is X, small deflection, with 2 theta into F, where F is the focal length of the lens. So there are some certain important points we have to consider whenever we are checking the angle by using Autocollimator. The position of the final image does not depend upon the distance of reflected from the lens, that is the separation X is independent of the position of reflected from the lens. But if reflector is moved too much back, then the reflected rays will completely miss the lens and no image will be forward. or it is formed. Thus, for full range of readings of instrument to be used, the maximum robustness of the reflector is limited. For high sensitivity, that is for large value of x, for small angular deviation theta, a long focal length is required. So this is the working principle. Now we are going to see what are the equipments used in autocollimator. Hope you understand the working principle. Now the equipment, that the lamp from which the light source is getting, then the diffuser, then cross-line graticule from where it is transferred to the beam splitter, from the focal length where viewpoint is there, that is the eyepiece, then collimating lens, the beam splitter, objective, then the reflector. So from the viewpoint, whatever the lamp producing the light, if the object reflector is normal to the light rays, then the objective will transfer the light rays, and viewpoint we are not getting any deflections. If the reflector is deflected, then we are getting some deflections at the viewpoint. So that how we are going to get, that we are going to see. So these are the equipments which is used in autocollimator, where if the reflector is perpendicular to the ray of light, so we are considering the two conditions. First, the reflector is perpendicular to the ray of light. When from the lamp the light rays are coming from the diffuser to the cross-line graticule, then it is transferred to the beam splitter. The beam splitter split the lights from the intersection and projected to the objective as parallel to the pencil of light, where in this mode the optical system is operating as a collimator. So from the objective it is coming directly to the reflector. When the reflector is perpendicular to the ray of light, then this reflector deflects the light rays again back to the beam splitter, and it is transferred to the eyepiece, and there at the viewpoint we are getting the straight line of lights. So this is the one condition. Whenever the reflector is perpendicular to the ray of light, means there is no deflection, as the reflector is lying perpendicular to the ray of light. So that is one condition. Then another case, when we are getting some deviation, means the reflected is tilted at some angle. So this angle will be theta. At this theta, the reflector is deflected to this angle. When the light rays is coming from the lamp, which fall on the diffuser, when it is coming from the cross-line graticule and cover at the beam splitter, then light rays beam projected to the objective, a parallel pencil of light we are getting. Now the reflector is tilted to some angle, so we are not getting this condition. So we will get a new condition, that angle theta, the principle of reflection, we are getting that whatever the deflected light will be reflected at a angle 2 theta from the objective, then it is coming to the collimating lens, to the eyepiece, then to the viewpoint. So there, this value of x we can calculate by using this formula, that is 2 theta into focal length. 2 theta into focal length. So here the flat reflector is placed. If the flat reflector is placed, then we are getting the correct viewpoint, that is no deflection in the light. If it is tilted, that tilted of the reflected, then we are getting some deflection of light. So there the angle of tilt or focus of the plane of the target graticule or cross-line graticule is literally displayed from the actual target cross lines by an amount 2 theta into f. So the linear displacement of graticule image in the plane of the eyepiece is therefore directly proportional to the reflector tilt and can be measured by an eyepiece graticule, optical micrometer or electronic detector system. where it is all scaled directly in angular units. The autocollimator is set permanently at infinity focus, and no device for focusing adjustment for distance is provided or desirable. It responds only to reflector tilt, that is not lateral displacement of a reflector. If there is a deflection at the surface, then that can be responded by this reflector. This is independent of separation between the reflector and the autocollimator, assuming no atmosphere disturbance and the use of perfectly flat reflector. So there we are getting this measurement of angle to theta, that is x. There are some many factors which are affecting the specification of autocollimator, that it is particularly focal length and effective aperture. The focal length determines basic sensitivity and angular measuring range. The longer the focal length, the larger the linear displacement for a given reflector tilt. And if the air currents in the optical path between the autocollimator and the target mirror cause the fluctuations in the readings obtained, this effect is more pronounced as the distance from the autocollimator to the target mirror increases. Further errors may also occur due to errors in the flatness and reflectivity of the target mirror, which should be at a high quality. So these are the some specifications we are getting whenever we are measuring at angle by using this autocollimator. Means small deviations can be measured by using this autocollimator. Now where we can using this autocollimator, means applications of that, we can use this autocollimator, that is optical instrument, for checking straightness of machine tool slideways. We can use for measuring small angles, checking parallelism. We can use for checking squareness of column to base. Also we can use for checking flatness of bed plates and surface tables. We can use for measuring small displacements, also checking small linear displacement. There we can use this autocollimator. So it is having some merits, that is advantages. It is very high accuracy. It can measure wide range angles. It is very easy to set up and operate. Calibration traceable to international standards. It can be used to see the results visually or electronically, that is on computer screen. Wide range of accessories and levels available. These are the merits. Now what are the demerits? Maintenance is required regularly, that focal length and all these things, reflector, that maintenance is required. It is time consuming, that the reflection what we are getting, based on that we have to calculate the angles, then we have to take the readings. All this will take the time. It requires sample cutting and processing for tracing the detector. So these are the demerits. If you see, we are using virtual autocollimators and optical autocollimators. So if we are using virtual autocollimators, then the whatever the readings we are getting, that we have to trace to the angular measurements. In optical autocollimators, we are getting the direct result based on the reflection of light. So in this session we have seen how the small deviations can be measured, angular deviations can be measured by using autocollimator, that the sample ray of light which is falling on the plane reflector, then we are getting the same deflected back ray light. If there is a tilt, means deviation is there, then we are getting the small deviation at the viewpoint, and based on these small deviations we can calculate whatever the deviations we are getting for the angular differences or angular deviations. So hope you like this video. If you like it, please stay connected and don't forget to subscribe my channel. Click on bell icon to get more notifications. Thank you very much.